In this video, I thought it might be useful to provide an introduction to basic turborocket engine operation, to explain the basic components and the basic functions of each of the components within the system. We begin by considering a basic block diagram or schematic of the turborocket engine system. In this drawing, we can see that the rotating elements of the turborocket engine are indicated in the dark gray color, while the static elements are the lighter gray color. The dark gray elements are known as the rotor assembly, and they are the parts that rotate within the turborocket assembly. The static components consist of those components that don't rotate and support the loads that are generated by the turborocket engine system. Within the rotor assembly, we have the main combustion chamber, where propellants are injected, mixed, burned, and produce a hot, high-pressure working fluid, which emerges from the rocket nozzles, also present within the rotating element of the rotor assembly. Propellant injectors at the outside edge of the rotating elements inject propellants, which could be a fuel and an oxidizer, at high pressure into the combustion chamber of the turborocket assembly. Rotating forces are supported by the main bearings of the turborocket element, whereas secondary bearings can also be used to support other elements within the turborocket engine system, such as secondary seals or other aspects of the turborocket engine. The fuel seal shown here prevents fuel from leaking past the main bearings and out of the body, while the inner propellant seal, probably the most important seal on the turborocket engine system, keeps propellants from mixing prior to being injected into the combustion chamber. They're located between where the fuel and the oxidizer enter into the turborocket engine system. The basic operation of the turborocket is accomplished by injecting propellant into the turborocket engine body. When the propellant flows in, it fills various plenums before entering the rotating assembly through a series of passages. This allows the oxidizer to pass axially along the shaft of the turborocket rotor assembly before turning radially and entering the combustion chamber of the turborocket engine system. It fills the injector ports prior to injecting oxidizer into the main combustion chamber. Likewise, the fuel is provided in a similar way, but at a different station. It also fills any plenums within the body of the turborocket engine system before entering the rotating elements through a series of passages into the shaft and rotor assembly of the turborocket engine, before it too fills the injectors within the system. During rotation, the propellants are injected at high pressure within the combustion chamber, where they atomize, vaporize, mix, and burn to produce a hot, high-pressure working fluid. This working fluid, or combustion gas, exits from the turborocket through a series of nozzles. These nozzles are at an angle relative to the axis of rotation of the system and impart a rotation to the system. Inside the combustion chamber, the rotation imparts a radial motion and or effectively a pumping action of the propellants into the main combustion chamber and through the injectors of the propellants, respectively the fuel and oxidizer. They're injected at high pressure into the combustion chamber, where again, as mentioned, they mix, burn, and to produce a hot, high-pressure working fluid, which emerges from the nozzles at an angle. The axial component of the exhausting jet velocity is the source of the thrust of the turborocket engine, whereas the tangential component provides the power to pump the propellants through a centrifugal pumping action into the main combustion chamber and imparting rotation to the system. That's the basic operation of the turborocket engine system. While simple, certain aspects of it make its motion somewhat complicated and a little bit counterintuitive to understand. If you'd like to learn more about turborocket engine operation and see some hot fire engine testing, check out the other videos on this YouTube channel, Turborocket. And of course, if you like and subscribe, that directly helps the development of turborocket engine technology and encourages more videos and development that can be shown here. If you'd like to go into a really deep dive into the technical details of Turborocket Engine, please check out my new book on the subject, Design and Analysis of Turborocket Engine Systems. It's available on Amazon, and again, your support of this book by purchasing it helps the development of the Turborocket engine. Thank you, and I encourage your development, thoughts, and ideas on Turborocket engines for your own types of systems.